Hi guys, so in this video we're going to be learning how to find the area between two curves. So in this example, we have to find the area between the curve y equals x squared and y equals root x. So since we know what they both look like, we can actually just draw a diagram and represent them and then find the area in between them. So y equals x squared looks something like that, while y equals root x looks like that. And from our diagram, it's pretty clear that the area they want us to find is over here. So now the question becomes, how do we do that? Well, we can use it through integration. So first thing we need to do is find the two intersection points, and then we can put it into an integration equation that will make it a lot easier to solve. So the two intersections, as we can see, we can find by equating the two functions. So x squared is equal to root x. If we square both sides, we get x to the power 4 is equal to x. Bring everything to one side, we get x to the power 4 minus x equals 0. And factor, this is our result. So we know that x is either 0 or x cubed minus 1 is equal to 0, which means that x is 1. So those are our two x values in our two solutions. So this will make it a lot easier because now we just need to put it into an integral equation. So we've got our upper and lower bound. And since this is all above the x-axis, we can just represent it in one integral. But now the question becomes, what is the function that we're actually integrating? Well, when you have two functions, you have to subtract the lower function from the upper function. So in this case, root x is the upper function, since in this period where the area is in between the two intersection points over here, root x seems to be the function that's above, while y equals x squared seems to be below. Therefore, we would integrate the function root x minus x squared. And now we have the equation we can work with. So if we write it in terms of powers, that's easier. It should take the antiderivative or integral of. We can write it as, let me just bracket that, x to the power of half minus x squared dx, which becomes, and if we integrate it, it becomes, so integrating means we divide it by, so we increase the power by 1 and then divide by the power. So if we increase, so let's start with x to the power of half. So that becomes x to the power of 3 over 2 when we increase the power. And then we divide it by that. So we get 2 over 3x to the power of 3 over 2. And we know this is true because if we just take the derivative of that, that will give us x to the power of half. So we have 2 over 3x to the power of 3 over 2 minus, and then x squared. By 1 more, we get x cubed divided by the power, we get 1 over 3x cubed. This is our integrated function. Now we just need to apply the lower and upper bound. So when we do this, we get 2 over 3 times 1 to the power of 3 over 2 minus 1 over 3 times 1 cubed. And then that's subtracted from the lower bound. The lower bound in this case, if you notice, if you put 0 on all of these, it'll just become 0. So we actually don't need to subtract it from anything. And when we evaluate this, we get 2 over 3 minus 1 over 3, which is just equal to 1 over 3 units squared. So that's our calculated area. However, sometimes they may not give you a diagram, or you may not be able to visualize the curves for whatever reason. So we're going to go over an example of that and how to work it out. So in this question, we are given what is the area of the region bound by the graphs of f of x equals 4, g of x equals e to the power of x over 5, and x equals 0. So the x equals 0 is just one of the boundaries, or one of the so-called intersection, I put this in air quotations, that you will need. However, the other intersection can be found by equating the two other functions. So equating f of x with g of x gives us e to the power of x over 5 is equal to 4. So e to the power of x is equal to 20. So x is equal to ln 20, which is approximately equal to 3. But we can't use x equals 3 since that's not very specific, so we're going to be using x equals ln 20 instead. Now, the important thing we need to do is be able to recognize which function is above the other in between this range. So in between 0 and ln 20, which function has a greater value, essentially? And the way we can find that out is substituting any value in between 0 and 3, since those are the only 2 points where the graphs like cross over. And we can use, for example, 1. So if we substitute f of 1, that just gives us 4, since 4 doesn't have any x component in it to change the value of it. Then g of 1 becomes e to the power of 1 over 5, so that's just e over 5, which is equal to, so let me just put that into my calculator, divided by 5. That gives us about 0.5436, but that doesn't really matter how many decimal places we write this out to. 4 is greater than 0.54 ... So that means f of x is greater than g of x in this region. So when we're writing it out our integration statement, we are going to have to, so we use the bound ln 20 and 0, but we're going to be doing this of the function f of x minus g of x, which in this case is 4 minus e to the power of x over 5 dx. So now let's write this out in our integral form. So integral form of 4 minus e to the power of x over 5 is 4x minus e to the power of x over 5. Since e to the power of x just becomes e to the power of x when differentiated, e to the power of x also becomes e to the power of x when integrated. So our integral is 4x minus e to the power of x over 5, with the bounds ln 20 is the upper and 0 is the lower. So when we evaluate this, we get 4 ln 20 minus e to the power of ln 20 over 5 minus, and then if we put our lower bound in, we get 4 times 0 minus e to the power of 0 over 5, which gives us 4 ln 20. And then e to the power of ln 20 is just 20, so we get minus 20 over 5, minus, and then minus 0, but plus 1 over 5. So we get 4 ln 20 minus 19 over 5, which becomes 20 ln 20 minus 19 over 5, which if we put this in our calculator, let me just do this out right now. So 20 ln 20 minus 19 divided by 5, that gives us roughly 8.1829 units squared. So that's our answer. So thank you all so much for watching the video. I hope this helped clarify anything about area between the curves, and bye for now.